Okay, so to get a more precise price of a bond, we need to look at the actual characteristics of the bond. So in particular, if we're talking about defaultable bonds, we have to look exactly at what is the seniority and collateral and so on of the bond, such that we can determine the recovery rate. And we also want to specify exactly what is the probability of default of that firm and how that probability of default may evolve through time. Okay, so one way of doing that is to think about the bond in this fashion here, which is to do a tree for the cash flow. So what we have here is an example of a bond that has 3 years into maturity. So we are here at time 0. We want to find the value of the bond today. We know that the cash flows are going to be a coupon 1 year from now if the bond is still alive, another coupon 2 years if the bond survives 1 more year, and in the end coupon plus principal if the bond survives again 1 more year from 2 to 3. If the firm defaults in the first year, which will happen with some probability of default between 0 and 1, we will get the recovery rate, and we assume that both coupon and principal become due at that default moment, but we just get a fraction, say 40% of that. Okay. If we are still alive at the end of the first year, then in the second year we may default with probability PD between 1 and 2, between here and here, and we get again that recovery from principal plus coupon, and so on. We keep evolving like this, right? So if we specify these probabilities using objective or real world or physical or measure P probabilities of default, so all these are different ways of saying that this is the true probability that the firm will default or survive, so real world probabilities, then what should be the price? Well, it's just the sum, the present value of all these cash flows, where each cash flow has to be multiplied by the probability of we getting there. So this cash flow we will only get to this cash flow with this probability. We'll only get to this cash flow here with this probability. We'll only get to this cash flow here, see if we survive for 2 years, so this times this. We'll only get to this cash flow here with this probability that comes from this one times this one, so surviving for the first year and then defaulting on the second year, right? So this would be the probability of this branch, and the probability of the third branch would be this times this times this, okay? So putting all together, this is what we get. The value of the firm, or the bond, sorry, V0 is the sum from now until the maturity of all the cash flows in the good state. So this is the coupon or the face value at the end. So including the face value at the end. So from year 1, year 2, and so on, multiplied by the probability of surviving until that first year, second year, third year, and so on. And then this Z is the discount factor to bring the cash flow from that future date back to the present, right? And this D here stands for defaultables, saying that this is the discount factor appropriate for the risk of this bond, okay? And then second sum is all the cash flows in the bad states, in the default state. So this is the value we get if there is default. This is the discount factor to bring this back to today. And these are the probabilities of getting to those default states. So this is the probability of surviving until the beginning of the period, and then this is the probability of defaulting in the last year. So for example, that last term would be probability of surviving from 0 to 2 times the probability of defaulting between 2 and 3. Okay. So where do I get these probabilities of default, and therefore these numbers here? Well, I can get this from all these methods we have been discussing before, the transition matrices, from internal credit scoring models, or we can even do other more sophisticated models like these ones we have seen from KMV ZDF. Okay. Now the problem here is that this cannot be really implemented in practice for the following reason. I don't know what should be the discount factor I should use here. What should be this ZD? The problem is the following. So suppose I would get this from I could get these Z's from a risk-free rate plus a spread, like a Z spread, like we have seen before. But how do I estimate the Z spread before? The Z spread is estimated using best case cash flows, meaning the cash flows of the firm when it does not default. So if you recall the calculation of the z-spread, what we would use would be these cash flows here, these C's, right? And I would find the spread in addition to the risk-free rate. Therefore, that z-spread has included in it a compensation for the credit risk of this firm, right? Because it was coming from market prices and best case cash flows. So it has to have a credit risk compensation. But now, in this framework, I am not using just the bad case cash flows. I am using also the cash flows in the case of default. So I am adjusting for credit risk by decreasing the numerator, by decreasing the cash flow, because I consider that in some states of the world, I'm not going to get the full C, I'm going to get something less, right? So if I was going to compute the price with this framework here using a discount factor based on the market Z spread, I would be, with these things, I would be double counting the credit risk of the firm. I would be counting it once in the discount factor, and I would be counting it twice in the cash flows by reducing the numerator. So this would be wrong. So I cannot use the real physical probabilities of default. Okay? So I'll continue in the second video.